we might start off with the recent debate on mitochondrial transfer, which has been so much in the news, and to talk about that a bit. I mean, as you will remember, the debate has been over the issue of whether or not Parliament should allow regulations to go through to the regulatory authority, the Human Fertilisation and Embryology Authority, to allow the transfer of mitochondria, which carry DNA, into the egg of a woman whose genetic heritage means that she may pass on a mitochondrial disability to her children. And in order just to explain that to the non-scientists, we have about 3 billion base pairs of DNA in our alphabet, which is contained in the nucleus of the cell. And in addition to that amount of DNA, there's a tiny amount in the mitochondria, which are these small organelles which regulate energy. They regulate the Krebs cycle and other aspects of our chemistry, which are held in the cytoplasm, in the substance of the cell. And the mitochondrial DNA accounts for about 16,500 base pairs, and there are some 30-odd tiny genes which regulate that energy, and occasionally mutations occur. Actually, not infrequently mutations occur, particularly as we age, which modify the mitochondria. And so consequently, some babies born with mitochondrial mutation are likely to have pretty serious defects which they would pass on, if they survive, to their children if they're female. It turns out that the sperm does not carry mitochondria into the egg, so it's the egg cell which is responsible here. So the female is indeed more deadly than the male, more deadly species than the male, in this instance only. And the thing has been colloquially called three-parent families, which in my view is a nonsense, because the amount of DNA which would be transferred with mitochondria is less than 0.01% of DNA, so it's a tiny amount. And indeed, of course, any of you who have had a blood transfusion will have actually be carrying much more DNA, at least temporarily, from another person than you would with mitochondria. And indeed, those of you that have had a renal transplant, I don't imagine that many of you have, but if you've had a renal transplant or a major transplant of tissue, then you're carrying a large number of genes and regulatory DNA which will be in that tissue which is transplanted. The difference being, of course, that mitochondrial DNA is inherited. So, in fact, it's like a permanent blood transfusion, if you like, at one level. Moreover, the mitochondria are not really concerned with what we see as our phenotype, that is to say, our characteristics. So the argument really has been that this is a pretty trivial procedure. This is what the scientists are saying. Of course, the antagonists are saying, well, this is genetic modification, and it's the start of a slippery slope. That actually, if we allow people to modify the genome in any kind of way, even if it's only mitochondrial, then there is a risk that ultimately we'll start to want to modify the genome in a more formidable way, modifying intelligence, memory, height, strength, speed, and so on. Indeed, I think, in my view, that will definitely be possible using totally different techniques. May want to come to that in due course, but in my laboratory we've been working for some time now on how you might modify the genotype, the genome of large animals. And we are working with pigs, and we found a very efficient way of doing this, much more efficient than any previous transgenic technology, which allows us to get gene expression, certainly in small mammals, through several generations afterwards, and apparently normal gene expression, and with a very, very high efficiency, unlike any other transgenic technology. But that's a different issue, and maybe we'll come on to that. Let's just concentrate on the mitochondrial thing. You'll be aware, of course, that the thing went through the House of Commons without much debate. In fact, actually, it was a truncated debate, 90 minutes. And then it was presented to the House of Lords last Tuesday, I think it was. Can't remember. I know it was the night I had tickets for the opera, which I missed because I had to speak in the debate. I think it was Wednesday. And it was an interesting debate. And there were several things several aspects to it which I found very, very interesting. First of all, the people who were against mitochondrial transfer were not exclusively, but nearly invariably people who came from a religious persuasion, which actually is pretty querulous about the whole aspect of reproductive technologies. So, for example, most of the speakers speaking against it were people who would probably not approve of in vitro fertilization. And indeed, when it came to the eventual vote, the vote was invariably, overwhelmingly in favor of giving the permission to go ahead with a license if the HFEA was minded to do so. The thing I found interesting in that debate was that the people who were speaking against mitochondrial transfer, for example, one was a significant lawyer who'd been Attorney General, and she made a very strong point that in her view this was against European regulations, and therefore in fact we would be doing something which was illegal under European law. She almost got away with that argument, except that the ex-Lord Chancellor pointed out that actually in fact this had not been tested in the courts, and until it had, it couldn't be regarded as being against the law, that it would have to go through the courts first. That didn't stop her from continuing to assert this. And what was interesting, of course, was only subsequently that I began to realize that she hadn't actually declared a conflict of interests, because of course her interest was as a religious individual with a very strong particular religious opinion. She would never have agreed to this treatment in any case. Another person who was a doctor, a psychiatrist, another member of the House of Lords, argued that it was going to cause, there was a high risk of it causing problems in any embryo that was produced. And again, that person, who's the chairman of the British Medical Association's scientific committee, didn't declare that she was a highly orthodox Catholic. And of course, the arguments that she made as a psychiatrist were hardly relevant to people who were speaking from an embryological point of view or a cell biological point of view, who really had examined in some detail the issues. So I have no problem about people arguing from their own religious conviction. Indeed, I think that's a rather good thing to be doing in a place like the House of Lords. But I do think that it is unwise not to declare the interest or the basic persuasion that you're coming from. And I think that one of the issues that clearly came up in that debate, and I think one of the reasons why the vote was so heavily in favour of proceeding, was nothing to do with the law or to do with the risks of the procedure. It was because what people like myself were saying was that in a pluralistic modern democracy, it's up to the individuals concerned to judge what is in their own and their family's best interests. And that actually, in a society like ours, Parliament should have very little say in something which does not in any way threaten the fabric of our society. And actually, what is interesting was that I think more people went through the lobby on our side in consequence than they would have done had actually the Catholics in that assembly been rather more open with their persuasion, with their view. And I think that's quite an interesting point. I'm certainly not anti-Catholic. Indeed, I think there are many examples of Catholicism which are highly advantageous. But I think it is a risk for any one religious group to impose its minority view on a different group of individuals. And we're seeing that increasingly sometimes in our society in different ways. And I think that that's something which is really, for me, very interesting. Of course, one of the issues is whether this is a safe technology. And of course the answer is, if we are honest, and we said this, we don't know. Because of course ultimately, when we first did in vitro fertilization all those years ago, back in the 70s, we were standing on a precipice. We had no experience with the human embryo. We did not know whether or not we might be producing an abnormal baby or not, but we had done extensive testing as far as we could in various species to try to ascertain its safety. And certainly some years later, when my group did the first genetic screening of an embryo, and we transferred an embryo which we had removed a cell from, having identified the DNA and to look up a particular mutation to avoid that happening in that family. That was in 1989. We were, of course, working in the dark. We had, of course, taken cells away from small mammals. We'd done it in sheep. Anne McLaren, who, of course, originally graduated from Oxford, had done this in cattle. And we had not seen, any of us, in several species that have been tested, any abnormalities. Nonetheless, there's always the concern that you might be doing something which is particularly damaging to the human. It turns out now that this technique of biopsying an embryo is worldwide. I mean, it's a very common technology which is widely used, in my view, too often used, but that's a different issue. So I think one of the interesting things, I think, which really has been stimulating me this week is what are the bases on which we make our ethical judgments with these sorts of issues. And I don't know whether that's of interest to you or not, but I thought I might just discuss that a bit, and then we might want to answer some questions and maybe other stuff that, which comes up. And, of course, you have to understand that I'm not an ethicist. I don't have any particular background in philosophy, so I will be talking to people who have much more knowledge than I do. But it seems to me that essentially there are four. It's a bit like the Spanish Inquisition. I said there are four things we should consider, but there are probably five. But let's consider the four main issues which crop up in this argument. I think when we are doing any kind of science, the ethical principles really apply probably equally to engineers, actually. But let's say in medicine, it's probably more clear-cut. The first issue really is the autonomy of the individual in front of us. And so I think that one of the issues is, what do we mean by that autonomy? At what level should we be respecting the autonomy of the individual who decides that they want to have a particular treatment which they hope is in their best interest? What do we do about that? What is our responsibility? And I think that, for example, with regard to the mitochondrial transfer, ultimately, it seems to me that one thing is absolutely clear. Whatever experiment we do, the fetus cannot give approval. So whatever we do may affect that fetus, that child, and we have no control over that. But of course, we do accept in our ethics that on those circumstances, the guardian or the person in charge of that child or the parent would probably have primacy in that argument rather than anybody else. So for example, if you have a sick child in an intensive care unit, whilst the doctor's view may be important, ultimately I think the decision how that child is treated, providing there is proper information, has to be very much involving the parents. And so I think that really that is already a principle that's established. The issue of autonomy, of course, must mean that we are absolutely honest when we talk to the people concerned, that we ensure that we get informed consent, so that we give them all the information that we possibly can to make a wise judgment about what they consent to happen. And I think there has to be something also that we speak with clarity and we listen very, very carefully. Because if you don't listen to a person who's a patient, for example, then I think we are failing in our responsibility. I think also we have to be sure that wherever possible we tell the truth. I do accept that in medicine sometimes there are examples where we will not tell the truth because we think on balance of probabilities that actually the person does not want to hear the absolute truth. There are, for example, occasions, perhaps when somebody is riddled with metastases from cancer, when you might want to withhold that information on the grounds that that is just something they're not really ready yet to hear. So I think those are some of the issues. I think another issue is the confidentiality of the patient. What's very interesting in this particular example, some of you who've been reading the press carefully will notice that the Newcastle group who've been promoting this treatment had already broken that confidentiality by, in fact, suggesting that one of their patients would speak to the press. In my view, that's unwise. I think it's very nice to have the personal story of why that woman wants to have this treatment for her embryo or her egg. But I think the issue then, of course, is that she has, in fact, the risk of her own confidentiality being lost. If the treatment goes wrong, for example, or the child is in some ways damaged, I think that represents a very serious issue. I think there are a number of ways that I didn't feel comfortable with how, incidentally, the Newcastle unit managed this whole thing. I think, first of all, they generated far too much publicity. I think it would have been much wiser to have published in the journals under peer review and to have made it quite clear that they were not going to talk to the press until they had published peer review information. I also think that it was extremely unwise for them to say that, of course, if we don't do this, Britain will lose its primacy in being the first place to be able to do this sort of research. In my view, that's a very bad reason for doing any treatment. We do a treatment because we think it's going to be good for somebody, because it might help them, not because we're going to be famous. So I think that issue comes up as well. It's a wider point, by the way, it applies to all science, we're on this issue. And I think that one of the things that I'm increasingly aware of, that we as scientists talk up our science far too much. We tend to lose that wider view of our responsibility to the community. And I think we have to recognize that we need to be much more clear about the risks of making claims which later on are not justified. A very good example would be in so many, nearly all human inventions turn out to be useless for what they originally proposed and are useful in other ways that we never expected. And they usually always have a dark side as well. The classic example, I suppose, might be the laser. Einstein postulated the idea of the laser in 1905 with the special theory of relativity. 50 years later, somebody actually builds the laser, but nobody could think of a use for it. And it's only 50 years after that that we start to use the lasers now as a ubiquitous, amazing instrument which controls the internet, controls measurement, controls the sort of microscopes that I use in my laboratory, confocal microscopy, that is useful for quantum computing and memory and so on. But actually has a dark side as well, because of course the reason why lasers are funded so heavily in the United States is because it's part of their weapons program. So I think that that's quite a good example. And of course we all use lasers, we all use DVDs. So it's been used in all sorts of ways that we've never would have imagined have been possible when we check out of a supermarket, for example. So to come back to that issue of autonomy, I think there comes a point, though, when there's a very interesting dilemma. And that is, at what point does your autonomy as a treating carer affect the autonomy of the individual? So, for example, supposing somebody comes to me and I'm a religious Catholic or perhaps a very Orthodox Jew, and they're requesting a termination of pregnancy. What is my view about that? What do I do? Where does my autonomy come in? At what stage should my autonomy be respected? And I think that's a difficult issue. But in my view, I think that an ethical principle here must be that if you see a conflict of autonomy in that kind of way, then you need to pass that person on to another individual who may have a different view from your own. And I think that that's something that we don't always do. And I'll give you an example of that. When I was a physician in training in the 70s, but doing quite a lot of research on tubal reconstruction, fallopian tube reconstruction, to explain, I used to stand in front, a teacher used to stand in front of my class and say, "What am I?" And what he was a womb and two tubes, okay? And unless you're test tube babies, all of you spent, some 112 hours in one or other fallopian tube. And I got very interested in the fallopian tube. It's a fascinating organ. And I was reconstructing tubes, and I became able to reverse female sterilization really successfully, really almost for the first time. And we were so successful we could offer a sort of 90 to 95% success rate. And I attracted patients from all over the United Kingdom, not deliberately, it's just that they heard of this technique, who had been sterilized and wanted a reversal. And it was very interesting, and I published some of this work in the mid-70s because I wanted to find out why so many of these women wanted a reversal of sterilization. And they wanted a reversal of sterilization because they felt absolutely devastated about having agreed to being sterilized in the first place. They felt that they were no longer sexually a proper woman. Many of them said to me, I feel like an empty vessel during sex. Some were quite severely disturbed by having been sterilized. And some of them had had even broken up their relationship with a partner. One or two had even felt suicidal at various times. And these were not abnormal people. These were not people who were in any way mad. They were seriously affected, and they were requesting what is, after all, a major abdominal operation to have that reversed. So I started to inquire, and it turned out, of course, that the great majority of these women had been sterilized by a surgeon who was sterilizing them, providing on a provision. The sterilization was predicated, i.e. what they were coming for was actually a termination of pregnancy, and the surgeon said, I'm prepared to terminate your pregnancy under the Abortion Act of 1967, but of course, clearly you shouldn't be having any more children, so I will want to sterilize you. Now, that sounds pretty shocking, doesn't it? It will sound even more shocking to you when I tell you of the first 100 women, at least 6 were all younger than any of you in this room. They had all found themselves pregnant, and the surgeon, in an immense situation of power, whichever the surgeon was, and there were surgeons all over the country, have made this a condition of having the termination of pregnancy. So you see, one of the issues for medical people is that we have immense power over our patients, and the risk of that autonomy being, in fact, manipulated is very, very serious. It's very curious to think that the Nazi doctors doing those horrific experiments on children actually were very altruistic, some of them. They thought they were improving their society, but they'd forgotten a principle which is really important, and that is that, of course, they have to respect the individual in front of them as the primal issue for them. So that's something about autonomy. I think the next thing, of course, is that we recognize that there's a notion of beneficence. We do things which we hope will be good, helpful, curing, relieve the patient of pain, help them with a condition. So beneficence is a second issue, and that will conflict almost invariably with the third issue, which is maleficence, that is to do no harm. Because, of course, virtually any medical procedure that you can think of, even taking blood from your arm, can go wrong. You can get infected. So, of course, one of the issues is you have to weigh up the risks against the benefit to the patient. And so that's one of the issues, clearly, which is very much with the mitochondrial transfer issue. Are the risks of mitochondrial transfer likely to outweigh the benefits? And that was something I think we had to think about very carefully. In my view, the risks are undoubtedly there, but it's probable that at the very least we will remove most of the damaged mitochondria. So we will have an egg which has got a majority of normal mitochondria, and therefore one would suppose that any of these diseases which were inherited would be much reduced in severity. Now, what I haven't done is to explain why anybody would want to have this done. Let me talk about Lee syndrome very briefly so you can have a graphic idea of why I say this is so serious. A baby born with Lee syndrome looks normal when it's born. It's got mitochondrial damage, but it looks normal. But it soon is obvious that it's a bit more floppy than usual. It doesn't actually have such muscular tone. And when a baby starts to lift its head and support its own head, a baby with Lee syndrome can't do that. It then, in fact, starts to vomit, and it will be incontinent in a massive way. And after months, it's likely to start getting seizures. It will be up all night screaming with pain. And then, of course, that baby, with all the fits that it's having and the pain that it's having, of course, is then causing absolute disruption to that family, which is finding it's starting to fail to grow because, of course, it's not holding its food down. And then the next issue probably is that that baby is starting to go blind. Not long after that, a lot of these babies will go deaf. And eventually, of course, death occurs usually around 2 years with huge impairment of the cerebral cortex. They don't have the energy supplies being able to drive the nervous system. Bear in mind that each of us in this room, probably more in Oxford, at least 1/5 of your energy goes to supplying that intelligence, your thinking part of your brain. Probably in Oxford it's about 25%, but it's probably highest in, I don't know which, I won't say which college. Anyway, but I mean, I think that, that's something that we need to recognize. So what these families are seeing is not merely the most damaging thing that any parent can really see, which is the loss of a child, but actually the loss of a child after a devastating, debilitating, horrific disease. Now, of course, all mitochondrial diseases are different, but Leigh syndrome is one that's perhaps particularly graphic because it affects very small babies. It turns out that these things are rare, at least in childbearing families, but when they occur, they are devastating. So I think on the whole, the Beneficence argument isn't a very powerful one. I think the chance of doing good, if we looked at it purely on the scientific evidence, would seem to outweigh the difficulty of doing harm. The problem, of course, is that the inheritance of mitochondrial disease is rather complex. It turns out, and the reason why when I was first thinking about pre-implantation diagnosis all those years ago, we decided not to go to look at trying to modify mitochondria was because we recognized that mitochondrial myopathies, for example, muscle disease due to mitochondria, are not inherited purely, they're inherited partly in a Mendelian fashion. That is to say, there would seem to be some nuclear DNA involvement. So even if you got rid of all the damaged mitochondria, you may still have some problem in the nuclear genome which you haven't treated. The problem, of course, the scientists in Newcastle have got is that there is not an animal model for mitochondrial disease. There are no animal models we know of where mitochondrial myopathy or mitochondrial disease of any kind happens. So the last major issue in our ethical judgments is one that is going to be increasingly important in our society. And it's going to be obviously something which is going to be particularly important coming this May. It's the issue of justice. What is a just solution, in a just society? Now, for example, one of the issues might be that if mitochondrial disease was very common, which of course it's not, and it was very costly to treat it, would that be justified when health service resources are under massive stress? And of course, increasingly we're going to see, I think, in the next decade, more and more expensive treatments, many of them, of course, pioneered at the Radcliffe Infirmary, some of them, of course, at Addenbrooke's, and some of them, of course, at the college, at the university hospitals in Imperial, which are probably the three most research-dominating places at the moment. I suppose UCL as well, where there's huge numbers of new treatments being looked at, where we're going to be finding, for example, individual drugs for different individual cancers and so on, which are going to make massive difficulty for our budget. And so one of the issues a medical practitioner may need to face is whether or not it is justified to use a diminishing budget to treat an individual just to keep them alive for an extra 6 months, for example. And that's a very, very big problem. I think in mitochondrial disease, it's a bit easier because we're looking at something which is rare. We're not looking at something which is massively expensive because there are a large number of women, I suspect many people like yourselves, who would be prepared to donate an egg for a family like this, given the nature of the serious disease that is involved, and that egg could then be used for mitochondrial transfer. So I don't see that being as a fundamental problem of justice yet. There is another fifth issue, and I mentioned that it's a bit like the Spanish Inquisition. And the fifth issue is the question of scope, and by that I mean what Rhiannon Gillon talks about. He was professor of ethics at Imperial College until he retired some 10 years ago. And Rhiannon Gillon points out that one of the ways we judge our ethical attitudes is by normative values in our society. What does society think? What does the man in the street think about, for example, doing this sort of treatment? And it seems to me, from what we got from correspondence, from newspapers, from where we could glean information from responses to inquiries by the regulatory authority, that the average person in the street feels quite comfortable with the idea of doing this kind of treatment. And I think those issues were really very important in finally getting that massive, overwhelming vote in Parliament. Now, of course, the problem is that we've now, as supporters of this treatment, gone on a line. If in 2 years' time the first baby is born with some hideous defect, of course, then that may have a massive effect on the progress of this kind of science. And I think that's one of the issues that we have to think about, that when we make scientific judgments, we have to recognize that that's why I think as scientists we need to be extremely modest. And I think sometimes we're not modest enough. I think very often we think of things in terms of a breakthrough. We think very pleased with ourselves. I remember the first time I looked at a stem cell from one of my embryos, which Michael Schneider had dosed, and there was a beating block of heart muscle under the microscope. I mean, it's kind of mesmerizing, and it's beating actually at sort of 70 beats per minute, and you think, my goodness, you know, here is a piece of muscle that you could transplant once you've solved the immune problems. And I think it's very easy to get carried away by that sense of awe, but also the sense of being just a bit too clever. So I think those are the things that I want to start off with. I've spoken for quite long enough, and I'm very happy to answer questions about what I've said or about anything else.